Hi, this is Raphael Mudge, the creator of Cobalt Strike. Welcome to Part 8 of Advanced Threat Tactics, Malleable C2. In this lecture, we're going to talk about how to change the indicators in Cobalt Strike's beacon payload to look like another actor on the wire, or even to look like something completely innocuous. That is up to you. We're going to describe malleable command and control, talk about how to set up and use it. I'll take you through the profile language, and I'll talk about how to test profiles. What is malleable command and control? Malleable C2 is a domain-specific language that gives you control over the network indicators in Cobalt Strike's beacon payload. To use a malleable C2 profile, just start a team server with the malleable C2 profile. It's the third option. What is a profile? A profile is a text file with our malleable C2 directives. The information you see here on this slide has direct control and direct effect on what you see in this Wireshark traffic capture. This is beacon traffic transformed and defined by the previous malleable C2 profile. Let's go through it piece by piece. At a high level, malleable C2 profiles let you define indicators for each of beacon's transactions, okay? So beacon does HTTP GET to download tasks and HTTP POST to send output back. And within these code blocks for HTTP GET and HTTP POST, you can define indicators for each of these transactions. Within these transactions, you can define both client and server indicators. So here we're specifying the client and server indicators for the HTTP GET transaction that beacon has to do, okay? The client indicators go into a client block, the server indicators go into a server block. Now, one thing you may do as well is use the set option to set options within malleable C2. You can set an option outside of a transaction block, and that option will apply to all transactions. User agent is a great example of this. You can do set user agent, whatever user agent string you want to use, and that user agent value will apply to HTTP GET, it will apply to HTTP POST, and it will apply to beacon's staging process as well. Within a transaction block, you can use set to set an option that both the client and server have to agree on. So in the case of HTTP GET, both the client and server have to agree on which URI the beacon is going to phone home to. So you do set URI, whatever URI you want the beacon client to call back to, and you want Cobalt Strike to bind to in the web server. Malleable C2 gives you many options that you may set. Two of the options that are pretty important are sleep time and jitter. Sleep time controls the default sleep time of the beacon, and jitter controls the default jitter factor of the beacon as well. You can change those in a malleable C2 profile. I already talked about user agent. Max DNS lets you restrict the length of DNS requests that the DNS beacon makes on your behalf when sending data back. If you want to learn more about these options, consult the malleable command and control documentation. Besides setting options, malleable C2 directives can also add arbitrary indicators to dress up a beacon transaction. Here, I'm using the header keyword to specify which headers the beacon should send when it does an HTTP GET request to its Cobalt Strike command and control server. Okay? These headers actually have no effect on the communication that's taking place. They are merely there to disguise the transaction further. And you can specify headers for both the client transaction and the server transaction as well. So besides headers, you can also specify arbitrary parameters. When you do parameter key value in a client transaction, Beacon will append that parameter, that key value parameter, to the URI it makes a request for, okay? So that's another way to dress up your transaction with extra indicators. The big thing Malleable C2 profiles do is they transform and store data, okay? I like to think of Malleable C2 as user-defined storage-based covert communications. And this ability to transform and store data is why. Each Beacon transaction has to send some sort of data somewhere, okay? In the HTTP GET transaction, the client has to send metadata, okay? And you get to specify how Beacon does that by specifying a metadata block and telling Cobalt Strike how it should transform and store the metadata it needs to send. Here's how that works. We have a metadata block with 3 instructions. The first instruction in that block says netBIOS encode our metadata, okay? So we netBIOS encode our metadata. And netBIOS encoding is a form of encoding that uses the first 16 characters of the alphabet to encode each nibble in a byte. So it essentially doubles the length of the metadata. Next, we say append the string dash.jpeg to our netBIOS encoded blob. So we do that, okay? So we now have our netBIOS encoded metadata dash.jpeg. The last line specifies where in the transaction we should store this encoded blob. And so here we're saying append it to the URI. So we're actually storing our metadata in the URI that the Beacon makes a GET request for. Now the Cobalt Strike server takes the same directive for the metadata and interprets it in reverse to recover the metadata. So in reverse, here's what we've got. We, the team server, know that the metadata is stored in the URI, okay? So we go ahead and rip the extra data off the URI, and we know the stub of the URI, so we can do that. And what we have now is this blob of stuff dash.jpeg. Now we can take the append instruction, dash.jpeg, and we know that that is 5 characters. So if we remove the last 5 characters, what we end up with is a netBIOS encoded blob of stuff. And if we execute the netBIOS decode process, we end up with our original metadata. So this is how we're able to chain multiple transforms together and use it to store data and recover it. This data transform language consists of reversible operations that allow us to tell Cobalt Strike through the Malleable C2 profile how to send data, and by telling it how to send data, we're able to derive how to receive data. Now the data transform language has several primitives. There's append and a string to append data to a blob. There's base64 to base64 encoded blob, netBIOS to netBIOS encoded blob, and netBIOS U to use uppercase characters in the netBIOS encoding. And then there's prepend string to prepend data to a blob. And you can apply these in any number within reason, and you can apply these in any order. When you use the data transform language, there are 3 terminating statements, okay? The terminating statements specify where you can store metadata, or in the case of a post request, the session ID. The 3 terminating statements are URI append, to append the transformed data to the URL. There's header, to store the transformed data in a header, and parameter, to store the transformed data in a parameter on the URL, okay? In the case of client and server output, you have to use the print keyword to just say, send this back to the client. And that's the only option there. One tool that's really going to help you a lot when you make profiles is C2Lint. C2Lint is a tool included with the Linux distribution of Cobalt Strike. And what C2Lint does is it compiles the profile make sure the syntax is correct. It also runs several unit tests against profile to make sure it's sane. And C2lint will also give you a quick generated preview of what the profile might look like on the wire, which greatly aids developing the profile and trying to make something that looks very close to what you'd see in real life.